Okay, good afternoon, everybody, and welcome to the IT Kolledž 33rd public lecture, which is titled Unexpected Ways How IT Meets Art. And I have to say that finding this title was quite interesting task because things what Mar and Varvara have done were quite unexpected for me and quite interesting and fun. And without further ado, please, Varvara and Mar. Thank you.
Okay, thank you for coming, and thank you for suggesting actually so straight to the point actually the title. And maybe we briefly first introduce each other. And well, we will speak in English, but questions afterwards you can also ask in Estonian if you feel more comfortable. So I can reply in Estonian or will translate also for Mar. But I am, actually we have both backgrounds in IT and art. So maybe that's a key point why our practice is related to, so like is described by this title. And my first degree actually comes from IT College, so I'm alumni of this educational institution. But I'm second time only here, so I was graduating when the IT College were in Sakala building. And then I did my master in digital media and art in Germany, and I have worked in Austria, in Art University, in Department of Interface Cultures, which deals with interactive art, and now I'm doing my PhD in Estonian Art Academy, and of course we are doing our art projects. Well, with Mar I work together since 2009 as an artist duo. So maybe you talk about first.
Hi, I am Mar. I'm from Barcelona. Recently moved to Tallinn with Barbara. Well, as you can see, with couple, and we have a baby coming very soon. And we decided to move here. But well, I am originally from Barcelona, and I started studying in Barcelona digital design and electronic art in a private university. I decided this thing initially because I was interested in IT, but I didn't like the IT degrees that were in Spain at the time. There were more business, software engineering, and these kind of things. And I learned programming in that university, but was more like web development and these kind of things. But I became interested to art as well, and I was starting to work at the beginning of the dot-com bubble for some companies. And then when I finished my first undergrad in design, I started to work lecturing in this university for 2 years. And after 2 years, I moved to England and I studied computer games development because I thought that was I needed a computer science degree to really program in deep. And I chose the more hard in programming, that it was the real-time computer graphics that were I specialized in shaders and these kind of things. But at the same time, at that time, I was already doing art projects. And in my summer between the second and the third year before graduation, I applied for Google, and unfortunately I didn't get in. Maybe for a wrong decision that I wanted to go to Silicon instead of the office of New York. That's what they told me. And then I went to Future Lab, which is in Austria, and it's like a laboratory for interaction that is inside the Museum of Arts Electronica in Linz, which is a leading institution in new media art in the world. Actually, it's a leading institution. And in there I worked for 2 years, nearly 3 years, and I studied in interface cultures, the master on digital arts of Linz University. And since the last maybe 10 years, I've been doing art projects in the art and technology.
Yeah, and in the last 3 years, we have been dedicating full time on creative projects as let's say freelancers. Well, what we are going to do today then is to introduce maybe our last projects. We have much more, but maybe last and more interesting projects. So we will start from the one which we actually spent the whole summer and more working hard to produce this work, and it's called Binoculars to, Binoculars from. Well, the idea is simple. It's talking about surveillance and also like our desire to view the places where we are not. So it's also referring to Mark Auge theory of excess of time and ego and space, that we want to be everywhere instantly and in multiple spaces. So basically, the audience can look inside the binocles and see in real time different cities by selecting the city they like. But at the same time, also their eye gets captured and is traveled to the place which is viewed. So actually, what is happening, the observer is also observed on this space where he or she is looking at. Why it was so stressful during the summer? I mean, because the project was realized in the frames of Connecting Cities project. It's a European project between a number of cities, I think 17, and in spring we thought we will have to show the work only in 3 cities, but in the end we had to show in
9 cities.
In 9 cities.
Yeah, the idea of the project came because of these connecting cities. They had this simple idea, the one project that connect different cities, and then we thought about this idea of making a binocles that the city you're looking, it reminds a touristic binocle that you will augment with a lens or something, but instead of looking in the same city, you can look other cities and also the same city through the camera that there is installed, but then your eye goes to the city that you're looking.
It's kind of opening real-time windows between the cities, and also, inspiration was this, and also this panoramic binocles, which you see in touristic places, but instead of seeing the view in front of you, you can see actually a totally different space.
I think our projects are really interesting because first, because many times you challenge the technology, and second, you're working like in a way the essence of, like, for example, a startup, that you have to be low cost. You have to be really looking that you cannot spend so much money. Like, you are not like a big corporation to spend like tons of money. Means we have to build everything, starting from the software. We had 2 servers dedicated to this project, and
we explained the process. But this was the previous one was in Helsinki. Every city they had their own realization plan. So in Helsinki they put outside near the metro station, and here you could see, like, you could look either on this city which you are standing at the moment, and appear on the urban screen, or some cities that were using projection or so on. Or if you are looking the other city, your eye will appear there, basically. The others will see it.
Even the photo looks like, I don't know,
it's because LED screen.
Yeah, the LED screen, when you make a photo, it looks different than what it looks when your eye look into it, because of the refreshing thing.
So
it's a simple photo. It's a simple image without no modification from the camera, like in the other one. More like this one here.
So this was in Berlin, where they have from the back the projection on the window, actually. Hungaricum Collegium. And there was 9 cities in this project, and actually it's still the last week. It's up in Madrid and Linz in Austria, and I think the main event was this from 6th until 7th
We had 7 cities.
Yeah, were 7 cities. Like we had basically what it meant. There is 2 streams per city, so it means we had to handle like 14 streams. Yeah, and it was quite challenging. Like in the last setup night, was good that we installed 2 servers, because in the last night of setup, it was like, oh, delay is too much, so we had to move some streams to
balance
another.
The streams. We had no experience before in a streaming. Yeah. We had to learn everything from nearly zero. Yeah. I mean, we know some technology that was used for streaming, and we didn't rely in API of YouTube or whatever, like we rely on open source. I mean, we try to do an open source technology, and we did this one is in ICAS, is a really old streaming server that exists for OGG. Fedora is like OGG is the packet encapsulation, and Fedora is the encoding system, which actually is really used nowadays for HTML5, because it's the oldest, is the one that is compatible to all the browsers. Otherwise, you have to rely on Flash again. And,
but in the end, we did the whole like receiving streams and sending in the GStreamer, the Python GST, and because, well, HTML5 we used for monitoring system.
Yeah, we had because we did basically we had 2 implementations, and then we used the one that was more stable. We did one in HTML5, which it was working, but the problem was that sometimes when it lost the connection, didn't came back. We overcome the cache thing and these kind of things, but sometimes it didn't come back, and you will need to reboot the browser after several times of dropping the connection, which was normal. And instead we use a pure Python and use the GStreamer, which is a huge library for dealing with video manipulation. Yeah. And I guess you will know GStreamer. I mean, GStreamer is super big, it's super stable, and actually, it happened that one of the cities, like because it had an installed camera, and didn't use our kind of suggestions, and we had to deal with the flash camera that, because it was this Sony that streams flash, and then we had to go with. I don't know if you're familiar with GStreamer. They had several kind of versions, and there is it's very funny because there is this good, bad, ugly, and we were in the bad in order to get the flash streams, and then this for some time until we just did it in another way. It was not good. Means it's a lot of experimentation in these projects. And then you realize. Well,
I mean, in all projects we never know how to realize, so it's always research, trying, error, and test and error, but we try to be totally sure before showing, because in some places it's 2 months is installed, and we don't want that everyone is calling us, hey, your stream is down. So we really we try to do as automated as possible, because and just to save our asses, so to say. Also,
it has been very interesting, how the people explain, and then they say, oh, well, why you didn't use Skype, or why you didn't use Hangout? It's I mean, tell me how to automate both really fast, and I will tell you that it's not that easy. Automate Hangout is even more complex. Automate Skype, that has an API, but I mean, everyone who had tried Skype knows that sometimes it doesn't work. You have to close the Skype and open again, and then tell me how you know that it's happening this thing, and then you have your installation just
I mean,
basically not working for several hours.
Even actually GIS TV, which has patches for pure data or max MSP, I mean, it works if you just have to stream this lecture and you put okay, start and stop, and someone is there in the booth and checks everything. Then it's okay if you have human power, but if you do some installation which has to run by itself. If someone like turns off electricity and in the morning they turn on electricity, it has to boots, it has to run basically. And there is no human power. Like, yeah, maybe there is a cleaning lady, but normally there is like no one who will
we had
be
to, since was running, for example, the stream for several months in some cities, we had to deal with all the exceptions, like the server reboot, the machine reboot, there are no internet.
Yeah, all these error situations.
Like all the possible situations that it makes complicate the thing.
Yeah. And well, but the project doesn't have only the, let's say, only software part. It's also, we want to a bit explain the whole process which we had to deal with. So here we also were testing like how to approach the viewer, the audience. So you have to think about the interaction model. So the stream is not like behind all. Yes, it's always streaming, but for the viewer, you cannot see all the time the city unless you really put your face inside the binacles. So the indication is actually the LEDs or the LED window, what you see on the photo, like the LEDs go on and then you can see the connection or connecting city. And in order to change the cities, because in some moment like people could view the 7 cities, so go through, there is a physical button. So here is a bit about the process. So of course we had to, why LEDs also? It's we had to capture the eye, and we used actually just a webcam, which was quite good one, which takes good images, Logitech 920. And yeah, so we had to. First, we use a lot in our work digital fabrication tools. So what you see on the top left corner, I guess, yeah, where is Mar testing, was laser cut it. And we couldn't laser cut, well, first we thought, like, totally first idea that we will 3D print. But the thing is, like, then we heard, like, oh, but some cities they want to put outside. And then we thought that we can use Raspberry Pi for this, but then when whole software became too complex and too heavy, we thought, yeah, Raspberry Pi is out of the game, so the binacles, they become bigger and bigger. So we had to think also about the material. So if some installation is outside, you cannot put like 3mm MDF or plexiglass, because just someone comes, hits a bit, and everything is broken. Or even the transportation. So
yeah, at the same time, we needed to do, we did first a prototype, because you need to do always prototypes, and to do, for example, to know the sizes. And like Barbara said, well, we found at the end a good camera, but it was not so easy, to think which camera was the best, because you need a camera that really focus really short distance. I mean, we focus in 3 centimeters, or even less than 3 centimeters, and for the eye. And then also, the light is not trivial. I mean, to light up a thing for a camera, I mean, because I had experience from a previous project that I know that with LEDs, more or less how to do it with the LEDs, because the LEDs are the best because has a high frequency. Like you will not have refreshing problems in a camera, but if you just put like I don't know, like these kind of tubes or any kind of light, many lights, it will like have a low frequency of refreshment and will have problems in the image of the video. Basically, the flickering effects and these kind of weird things. Yeah. Means also we had to do test how to light up, that is enough light and these kind of things for the eye, and that it doesn't make too much shadows and these kind of things.
And as soon as you have something physical like light or the button, you have to use electronics. So we used Arduino, which we use quite often in our projects. I don't know if you are, I guess you are familiar with, but it's open source microcontroller, which is very much used by the artists and designers and hobbyists and even some professional companies actually.
We also use 3D printer for some stuff.
Yeah.
Like you can see here the holder for the power supply and the camera holder is also 3D print. And that's someone in Brussels, like I was installing last week, they told me, why you 3D print the holder? Why you didn't put just a simple, like a small tripod? I said, like, I mean, think about it a little bit and you will see that it's not possible to just put a simple tripod. Like we had 7 of those and we want easy calibration. Like you need to have something that when you go to a city, is in the right position. Like if I have a holder that has a high, and then I put there, and I know it's in the right position, and means it's kind of like things that came out, and then you understand all the things that you need, and it was a lot of work because I mean it's a.
Well, basically we used because we are familiar with digital fabrication tools, and how you get familiar is just by doing, basically.
Exactly.
We were doing all the parts to fit into the, so to say, Binoculars head, everything what we needed, like computer, camera, Arduino, and actually there was as well going inside the Motorola screen, which is actually used like you put like smartphone, just that you have screen and the keyboard. So for us was the perfect, the price and the quality was just a screen which goes inside, and then of course ventilator, which we also discovered that you have to have quite big enough hole that it's doesn't overheat. And also we had lots of experience like with this, let's say, server-like computers that it's
for example,
not so easy to find, which really like easily works. I mean, it's
we don't use laptops because the laptops has one feature that is not good for installation. That is like you cannot normally any laptop you cannot put like a server mode. Means it will go out the electricity and then it will go in and it will not boot. And this is a very simple thing, right? I mean, it's stupid, but that serves you a call from someone to call you and say, oh, the installation is done, how I turn on? Because of course this is closed and there is a key and these kind of things, and they will have to call me otherwise, and because we design everything that when it boots it opens everything, like we need server mode.
Let's move on. And then the main like structure, because you see it's much bigger, was done with CNC router. Well, we were working at Liverpool John Moores University the whole summer on this installation, and actually we were lucky because the students, they don't really come in during the summer, so we were alone doing the things there. And also, well, the hardest thing was to do the first one, and then we were mass producing, so to say, the 7, and we were even painting ourselves and doing even the shipping boxes because of the budgets what we have in art. But that's the heart, well, my heart or the handwork even. And here is a small picture of our monitoring system, which was in HTML5 done, and only for us because at like this crucial events where were 7 cities or 5 cities, we had to be online and monitor that everything is working, just in case, if something goes down or something. And it was quite useful that actually you see here was the Liverpool. This is like the view from the city camera. I think this was from Berlin, someone looking. This is the view from Berlin. Dessau, someone looking from Dessau. This is view on Dessau. So we had all, actually, for us, this was maybe the most interesting to look what is going on. So we move on to the next project, I think so. It was quite in details. And
you didn't put the video, did you?
no, I mean, if we have time, we can show
Okay.
the video of the binoculars. Maybe it's better. Yeah. So, well, let's explain a bit, and then we put the video. This project actually started from one interesting fact which we found out or heard, or I don't know. Sometimes inspirations just come. Basically, there is quite old statistical finding from '74, actually, from Borston and Borston, who found positive correlation between the size of the city and the speed of pedestrian. Basically, they say that bigger city, faster pedestrians move, there are faster services. And the smaller city, everything is slower. And then we thought, okay, that's quite interesting, but how we can relate nowadays to this? Like, is it the same? Like, what is happening inside the cities? So we were looking the open cameras, the traffic cameras, to see the cars and so on. But in the end, we thought, like, well, actually, we should look into social data, because nowadays lots of like social data is geolocated or geotagged and open or accessible, and it's quite descriptive about the moment, about the place, about the happenings. And since we like to work always with physical matter and the twist between the digital and physical, we thought, well, we want to do kind of the rhythm of the city and twist the meaning of the metronome. So we took the 10 cities and the 10 metronomes and assigned in real time the data coming from Twitter, Flickr, YouTube, and later Foursquare to the rhythm of each metronome in every minute. So you can actually have this kind of bird view on each city, what is happening. But at the same time, it's also kinetic, performative installation, which is always in flux, and it has its own.
Because we have so much like interfaces for your own data, yeah, but not too much interfaces like a bird view, like that looks like the overall picture. And that's something that was the idea, that you can see the overall picture of 10 cities and compare between how the activity is in the social media. And we get the data every minute, and we basically what we do is we quantify a month of data produced, and then we look each city with his historical amount of data from the last week, and then by this we know if it's in a peak of activity, or we normalize between his amount of data, and then we get like his rim right now.
Yeah. And it's also example how data can be used as an artistic material. So for instance, if the sculptor or painter is using, let's say, clay or the paint for doing their piece, then we use real-time data for in this sense. And it's really giving the concept and material to us.
Actually, well, this piece we will show next year.
Yeah, it's in May in hybrid art exhibition. It will be in the Design Museum. This Estonian Art Academy is doing.
And well, I'm actually now doing a similar piece. Well, not a similar, but inspired also with this, a new one also. For Telefónica. Telefónica is like the bigger telecommunication company in Spain, because now like many people is talking about this big data and these kind of things, and they're very interested on doing things on visualizing the big flows of data and this kind.
Yeah, and actually this work served as push or inspiration for or proposal for my PhD thesis, which is unaware participation. So I'm looking at or searching for different forms of participation and interaction. So here we are not talking about direct interaction or participation of the audience, but rather of observing or hidden participation, so to say, of the masses, because every rhythm is actually composed by the digital inhabitants of the selected cities.
And at the same time, these new ways of visualizing data are quite interesting because, I mean, we didn't have never a request from doing that, but I mean, we think, for example, would be great in a place where, I don't know, like an entrance of a building or something like this, because you never are bored to see this kind of visualization. Rather than if you see just a static screen, like saying, oh, this city has now 1,000 tweets, just in a screen, will be not as a rich experience like a listening 10 metronomes, his sound, which is quite interesting, right? And his aesthetics. But there is a meaningful data in it. I mean, you can see which is the metronome who go faster, and it has a direct correlation with the time that it is, which city is, what is happening in this city. I can tell you that when it's Super Bowl and in America, and you look New York, it's totally crazy. And if it's Friday in Istanbul, where we first show once, like when we thought that the metronome was broke. Well, the metronome, our code was broke. And it just was actually absolutely a huge peak of number of tweets. Like it was like 10 times more tweets than normal. Because everyone was tweeting, I guess, like where to meet, where to go, and from a normal hour, it was 10 times bigger. I mean, and what we realized, for example, in this project is that the bigger cities are huge variations. Like they have high peaks and down peaks really, really fast, and small cities are more constant. Yeah. They just like, they produce small but constant. Rather than huge cities, they've been much influenced by events, and in certain moment, it just like go up and down because they're huge producer. When it sleeps, like it never sleeps. The city in New York, but it's just like it's doing up and down really fast.
And we compare always city to itself. We are not doing this like to compare Tallinn to New York. It doesn't make sense. It will be always that New York is much faster. But yeah, what Mar is talking is sometimes because we tweet too much, so the Twitter goes over its capacity. And with what we want to say with this, that some people say, oh, but it's so chance-based. But we say, no, it's not. And actually, not we, but the other scientists have done the studies already on the usage of social data. And it's proved that it's possible to describe our behavior by the usage of social media. So you can see here that on the weekend, we tend to stay up longer and start tweeting like after 8 p.m. like a crazy. If we compare with weekdays, we don't do this. And we wake up later, and here probably like we start to tweet when we go to lunch, if we can meet a friend or something like this. I mean, who knows? But of course, I guess in the studies you can find them out. But really, like it's not only, of course, the social media is also very descriptive for the catastrophes, for the events, even before the mass media actually, and it's already proved and already seen and realized. So for us was like totally clear that this source is applicable and we can make sense of it. But also, well, what we couldn't do is, for instance, to use all kind of sources what we wanted, like Facebook. It's closed. I mean, we cannot take Facebook. the API of Facebook or data. So we had to use these social data sources, which has open API and sources.
Actually, we could that now, because now I'm doing a project with Instagram. Like we could add Instagram. Actually, Instagram has also API open. I mean, the idea is to add all the services, like have to not be a project of Twitter quantification, because that was not our idea. It was more like the city, like just like use different sources of data to know the activity in the city, and as much as possible, as much as are available.
Probably next we can
because I mean, we saw many artworks that they just say, okay, we take the Twitter because it's. I mean, now it's not anymore easy because they also has this. They have these limitations on calls in the API and these kind of things. Before it was not even needed authentication for retrieving data in the geolocation search and these kind of things. But yeah, I mean, just. And
a bit of about physical realization. It was also a research project for us, and actually we started in 2010, and we are constantly modifying this piece to make it more robust, more easily to install, and more automatic. And actually the metronomes which you saw, they are the second ones. First ones, they are Wittner ones, were from Germany. Which has better acoustics, that they really give a spring and it goes click, click, click. But for exhibition it was not so good, because after half an hour the spring is in its end and someone has to come and turn it again. And it goes quite hard, that it's to place there a motor is difficult. And inside the metronome, believe me, it's like a clock. So how to take it apart and put it together and that it still make click clack, it's a trick. So
and also we start to use servos, and we're using until now servos, but now we're going to change this thing actually very soon, because I mean, this kind of things that you're not experienced enough. I mean, we are not mechanical engineers, for example, and then servos are great and easy to use. You send PWD, like pulse modulation, digital pulse modulation, and it's easy to send to a certain degree, and they are fast. Means we were using down for moving the metronome. That's what we do. We do from Arduino, not from Arduino the normal, the Uno something. We use the Mega because we needed more pins and these kind of things. We already did 2 versions. The first, like Barbara said, like with manual power, and then we researched and we found these metronomes only sold in Japan from Yamaha, which is the one you saw the video.
Well, actually we found in Japan, because we were also doing presentation in Japan, and one professor came like, look, I have better metronome for you. And it was Yamaha metronome, which was hybrid. So it means like it has pendulum, but the sound is electronic, so you don't have to give a spring.
I mean, that you understand this project we had been showing like 5 or 6 times?
This we forgot to mention.
Like we showed like 6 times already. Like the last was in Buenos Aires last year.
No, actually it was in Australia.
Like we did a last in Australia, in Adelaida, just finished. And before we were in Buenos Aires, and before in Brazil in Belo Horizonte, and before
Spain, Germany.
In Germany in Augsburg, near Munich, and before in Girona, and before in Prague. Prague, they commissioned the piece, the Biennale of Art, and they commissioned, that's an interesting story. Like we first wrote a paper about, and we presented in a conference in Istanbul, and we presented one. And we went to the conference, and we put the metronome in the table, and we make it play for 1 minute. And then after we explained, what was that?
And then we got the funding.
And then we got the funding
Because
for
everyone was
producing
like,
the 10, which was our idea, for presenting in this Biennale of Art and Technology in Prague. And in there we show the first version, and after this we make the second version. And now we are about to make the third version that will use stepper motors instead of servo motors, because the stepper motors are more industrial and they are brushless and they don't break.
Well, there are also industrial servos, but they are much more expensive.
Yeah, but I don't believe that they don't broke never. We were looking for a military servos from Germany. They were saying that they never broke, but actually they broke. You only have to see all this now with the explosion of drones and well, the copters, these helicopters and these kind of things. They tell like, yeah, this servo has had life for 6,000 hours or some number of hours, because always broke. And because it's actually for the way are making these servos, that they're like, well, it's short, they're small, and they always like has an hours of working.
Yeah, that's only what you understand. It's not about like, well, it's also about how much weight they pull. In our case, they don't pull any weight. But the thing is, like, if you want that your servo works non-stop 8 hours, you have to spend lots of money, and still you don't know.
Yeah, but imagine like a quadcopter working with a servo that directs or something for, I don't know, 12 hours every day during 3 months, which is like typical exhibition. I mean, if it lasts for this much, it's great, no? Imagine like, I don't know, a drone, like now they're thinking on delivering post, the drones in France, for example, the quadcopters like delivering post. Imagine a post drone, like for 3 months, working non-stop, delivering post, and then broke the servo. That's fine, maybe. I mean, it can make a lot of work, deliveries, and then you have to replace one servo, which costs, I don't know, costs several, I mean, like maybe, depends, 100 euros, for example. But we want to make more robust, and then we want to...
So fast, maybe.
Yeah, I mean, technically, where everything is done in Python, the software of retrieving the data is in Python, because Python, we love Python, and Python is nice for taking data from the internet, like the web scrappers and this kind of things is easy to make. And then we also use like Arduino for. And then a database, but it had been changed actually recently. Like, we're not using MySQL, we're using SQLite, which is also enough for our thing. And then we don't need to open any MySQL in the computer, because Python is native with SQLite. And yeah, because it was kind of the driver for MySQL for Python. Sometimes in Mac, for example, is a pain in the ass to install. And SQLite is super easy, and we don't need that much. I mean, now we're also working in MongoDB. Some things is great.
Yeah. So if we find better solution,
we're always updating in the technology we think is then better for our needs.
Yeah.
I mean, that was a commission we did in December with the same project. Like we got invited in Sao Paulo. Actually, it's really interesting building. I had been working there for other projects, and not only also with Varvara. Last year, I think I showed 3 times things there. It's actually the Union of Factories of Brazil.
Yeah. And this is
the building of the Union of Factories of Brazil, like the industry of Brazil, basically. I mean, it's a very important building in Brazil. Of course, in the top roof, it has like a landing place for helicopters, and when I was there, it came the industry minister of Argentina, because like the director of the Union of Factories of Brazil, now is an emerging country, is really powerful person.
Yeah. And this is, that you understand, this is Paulista is like the main street, like Champs-Élysées in Paris. There is the main kind of avenue.
Yeah, it's four rows of cars in one row, in one way, and 4 rows of cars in this way, and pedestrian walking around a lot. It's like the more crowded street in South America.
For instance, just if you want to park your car there, is 1 hour, I think, was €7 or something like this. Yeah. So, and the parking are full, full also. I don't know how they.
And Brazil has really good policies on investing on art, and each institution, like for example, this is called Fiesp, like this Union of Factories of Brazil, invest I don't know, it's something like 10 or 15% of his budget on things for population, and one main thing is art. And now recently they installed this facade, which actually we were invited just in the opening.
And well, they also, maybe the reason why it was like for organizers easy to get money for installing the, let's say, digital architecture, so to say. Well, they have LEDs, like RGB LEDs in every this grid. I don't how many LEDs they have. A lot.
Yeah, it's not so high resolution, but it's not so low. It's like something like in the rooftop, it will be like 60 pixels, and down will be 100 pixels, but it's also the sides.
Yeah, so they covered everything. And the thing is, like, because in São Paulo it's forbidden, like, any public advertisement in the public space. So, for instance, if you see in Tallinn these big LCD screens and they put some, like, Solaris advertisement or whatever, it's not allowed. So it's called, actually that's why in São Paulo is known as a gray city. But art is allowed, and Pichazin is coming also from there. Is a special there graffiti, and it's famous for this. And this is actually, we got an honor to be one of the first work there to show, and it was also like, they showed us this building photo, which was triangle, and saying like, oh, can you make something for this, because we are going to cover it. And then we said, well, this is a metronome. And actually we wanted also to do something like a bigger scale metronome for one city. So it was really, we have also the video. The sound is not so important. But basically it's, in a way, it's kind of like digital age clock, so to say. In every city they have their own big clock, and here is based on the social data of São Paulo. And also the graphical realization was a bit different, because it's triangles, no? How you render it's a bit different than just a square. You have to take it into account.
But it's also nice that it's interfering with the people who is producing this data, because it's like from the citizens of Sao Paulo, like the visualization of what they're all doing there. And actually it was re-shown on February this year, because they were the anniversary of Sao Paulo city, which is not so old. It's like only 350 years, and it was like shown in the anniversary as well, during the week of the anniversary.
Yeah. And they always, like, the people who run this, let's say, facade gallery, they always want to do something interactive, but it's very difficult public space. There are lots of traffic. There are lots of people. You cannot really block the streets. And well, basically, for the curator who was curating the show, she was recording the video with her iPhone, and someone just passed and she was stolen the iPhone. So you are still in Brazil, you know. So you cannot really leave the things there like, oh, nice, you can interact with these sensors or iPads. It can happen that it's just gone. But they are still trying to do like more interactive things. But yeah, every public space, it determines its own frames. And maybe the last thing, and a bit different thing, that to introduce the knitting, open source knitting machine. So we also knit. And we started with one project which we got idea. I later, if we have time, I will show also, called Spam Poetry, that we want basically to knit what we want with old knitting machines. They are brothers from 80s. And it's an interesting thing because we have been using a lot digital fabrication tools, which are quite recent, like 3D printers, laser cutters. They are like, well, recent for, let's say, normal people to access. They are also open source and so on. But no one is like talking about textile fabrication, which was the way before this open source tools. So, for instance, electronic knitting machine was the first digital fabrication tool at home, which was already 76, just 3 years after personal computer at home. So, and then they stopped producing in 96, and everyone just forgot. Probably because the mass production of clothes, and well, Brother is also a Japanese company, and they thought it's not profitable anymore. So we started to work with this knitting machine because we got the idea to knit something and control with computer. And there were some hacks, existing ones, that, well, how this machine works. Basically, since they are from 80s, you still have to use floppy to upload the pattern to the machine.
But the floppy, not to mistake, the floppy is not a floppy that you can put in a computer and then send to there, because it was a proprietary software, everything. Yeah. And then the floppy had an arrangement of sectors different than the computer had. Means you could not write from the computer this floppy. No, because that was a confusion at the beginning. Yeah. Like it was floppies, but and they could change with floppies, but you need a floppy drive that was done for purpose of this. And actually, what it does is actually it dump all the memory from the machine to the floppy, and then it send it back. All the memory. I mean, it's kind of a but it's like saying, like what Barbara said, that is what now MakerBot is doing. I mean, I saw first time in Spain that one MediaMarkt is start to sell MakerBots in the MediaMarkt. Actually, I think it's the first MediaMarkt in the whole Europe that will sell MakerBots in their. Like, let's say you can go to a supermarket and buy a 3D printer.
It's like you go to Click and you buy your 3D printer.
And what this sounds revolutionary, that you can just go and buy a 3D printer in the supermarket, like the knitting machines that were in the 80s in the supermarket. Yeah. And it were digital machines. And that's what actually, like 1 year ago, we were here?
Maybe, yeah.
Yeah, 1 year ago we were here, and we were in the park where the concerts are, and the big concerts are. And we were talking with Barbara, and me and Barbara were talking, and we said, we just finished one of the projects we will show. I said, we have to write this down, because like, I said to Barbara, look, there is no, like the digital fabrication from MIT, it had one big mistake. They forgot the knitting machines. They totally forgot. In their storytelling, they don't tell nothing about knitting machines. Like they say, I don't know if you're familiar with their terms, they always talk about these bits and atoms, like how to pass from bits to atoms, and how to fabricate from bits to atoms, and they forgot the first digital fabrication machine at home. I mean, not industrially, but at home. Like it was the knitting machines. They were at homes much more than maybe in 1 year will be 3D printers at home, and they were in the 80s. And we wrote about one paper, and we had a huge impact this year.
Well, Actually, we have written like more papers on this project, and we used to do, since we do so much research, we also try to write about our work. But actually, normally about this NITIC research, we do like another separate 1 hour presentation. So if you are interested, also you can check out nitic.com, and there are also videos and the paper and also explanation how we modified the machine, and we are still working. But basically, we opened the machine because we thought like it doesn't make sense to just like how people are doing, dump the memory and then try to simulate the floppy through Python, and then that machine understands it. So we wanted to do more like a real-time, computer-controlled machine. So we opened up the machine, and through Arduino, we are monitoring the sensors because it has left and right sensor where the carriage is moving. And the encoder that knows on which needle it is, and solenoids which pushing the needles. So we are controlling this, and we made an interface in processing, which basically allows you to upload your image or even modify your image in every row. And it is saying like on which row you are and how many stitches you have, and you can determine where you start your pattern. So like basic things, but you don't program on your knitting machine, but you do through your computer. And you can see here like we track also the carriage. And also we have produced PCBs for Arduino, because, well, here goes the connectors of knitting machines and transistor arrays. There are some electronics like needed.
It's a shield for Due, for Arduino Due. Then, well, I cannot say anymore the new Arduino, because I was in the Maker Faire ROM, and now it's a couple of newer Arduino. But before the summer was the new Arduino.
Yeah, because the normal one was too slow. So we passed the clock speed for the first time. But yeah. So this was the project actually pushed us into knitting, because we got the idea to knit spam poetry. So we were collecting spam from the people in order to generate automatically the poetry, and then we converted this to pattern, and we were knitting the sculpture, so to say, out of it. So
yeah, we thought that was interesting because the knitting is the first digital manufacturing system that it was, because the knitting factories, they were the cutting edge on the Industrial Revolution, and then was the first adopters on technology. Like punch cards, first industrial machine that was applied was knitting machine. Means we wanted to recycle the first digital waste, that is the spam, because it's a waste. It has carbon footprint. Carbon footprint. It generates like spending electricity in the servers and these kind of things. And the way to recycle was, okay, let's recycle with the first kind of manufacturing system digital. Yeah. And then it's kind
and also we wanted, because like in the digital field and space, there is like so much data. Everything is so fast. You just like how spam is generated is now automatically generated, and it's extremely actually smart how it is generated, because they even do on purpose the spelling mistake that your spamming filter doesn't like get it, that it says a spam. And well, we just wanted to this rapid process. We wanted to face this very slow and careful process of knitting. And also we since spam is so useless, we started to do dysfunctional forms. So we use all the sweater forms. So you see it looks like a sweater, but it's not sweater because it doesn't have a sleeves. So it's kind of a reference and, so say, artistic play to this. And then we had knitted also in Brazil some more well, not spam, but the combi, which was the knitted car, which we did the intervention with, and then we thought, well, we should do something even more crazy with the knitting and push it into the digital fabrication field. So I will just show you the video first. It's called neuroknitting. Yeah. So, yeah, so we decided to connect neuroscience to knitting and fabrication, textile fabrication.
Yeah, we released before the summer, and we got 50 blogs in 1 week, and 2,000 views in Vimeo. And the blogs were like Make Magazine, Esquire in America, like Stanford blog, medical blog, like it was featured for a week. And yeah, basically we now this project is the beginning of a new research that we have is in neurofabrication. We already wrote a paper and sent to a conference, and we're waiting for if it's gotten accepted. We collaborate with Sebastian, which is in the picture. He's a PhD candidate in Pompeu Fabra University in the Music Advanced group in Barcelona, which is a really famous group because had been getting many successes in the last years.
Mm-hmm. And we call actually this project, we call Discipline Border Breaker, because we have been contacted and this project has been featured by the press and the blogs of neuroscience, medicine, technology, art, design, craft, furniture, woman magazines, male magazines also.
Yeah.
Everyone thinks, and makers of course.
Yeah.
So everyone thinks that they fit everywhere.
The last thing that happened with this project is United Nations invite us to Geneva to make a presentation in the new manufacturing conference, like in when it is, I think it's in November.
Yeah.
We were last week. Barbara cannot travel anymore, but I was in Maker Faire Rome, which is the second bigger Maker Faire in the world after New York. And yeah, this woman from United Nations, like she knew it out already from our project, and she wanted to invite. She came just to invite us for presenting in this conference.
But what we have discovered, like through this, like also. We experience also again the difference between, let's say, Western, like American world and the Europe. we have been contacted by like business contacts saying like, can you make this on demand? So that there is actually not much services, or almost not at all, which will offer actually this kind of personalized knitted fabric. And because the thing is like what you saw in the video, we used music to stimulate the brain, and every minute, every second of the brain is actually one row of the scarf. I mean, it is scarf, but it can be whatever because it's a knitted pattern. So it's up to maker what he or she wants to do. But it's in a way the scarf is also the database of that moment senses of yours. Yeah, and this is as well like in terms of publication is a very unique way how to address it. Is the thing is like it's very personalized fabrication rather than just like downloading, let's say, from Thingiverse something and 3D printing. And in terms of on other hand, the textile design, so it's not the aesthetical decision of designer, but let's say the meaningful or the conceptual solution, so to say, because it has also the information inside.
Yeah, and also this personalization of products. Like not everyone is a designer. I mean, like some people he has this thing taste for personalize his Nikes in the website and make the best color, and then order it. But some people don't have this. Well, they're afraid of designing their own things or something. And this is a new design strategy: how to design things by brain interfacing with the product. And then, like the neurofabrication is I think will be huge in some years, and we believe this, and that's why we start to work on this.
Yeah, and then the brain interfaces are more and more accessible. Like the emotives they did just recently, the Kickstarter for cheaper version, and well, we used free main flows or the physiological senses as cognitive load, relaxation, and excitement. But that's why also we collaborated with Sebastian Miaia, who is doing PhD on this topic, because well, there are lots of other art projects which they use brain signals, but brain signals are also, there are lots of noise. So yeah, we didn't want to do the project about noise. So yeah,
it's a very complex area for sure, and well, I guess someone is familiar with the things, but it's basically you get the microballs in the cortex of your brain, and you get alpha, beta, gamma, and then you have to make a sense of it. And well, with pattern recognition and these kind of things, they noise filtering first before the pattern recognitions, then they are able to get some emotional states like we're using, and also pattern recognition for like emotive. In his SDK, you can train for simple actions like push, pull, and move left, right, and then these kind of things. In our case, we use the SDK just to get the raw data, because Sebastian has them. He had developed the algorithms for cleaning this data and make sense of it. And we know we are using well-known academic filters and algorithms that are proof that works and that we know. I mean, it's not the SDKs that are not good, but are black boxes that you don't know what you're using.
Yeah. And we, for this neural projects, we have been using mainly music as a brain stimulator. But I think we are a bit over time. So if you have questions.
Yeah, because hold on, brain kind of froze right now. But earlier you mentioned that you tried Raspberry Pi in the binocular thingamajigs.
This was initial plan, yeah.
But I don't know if I just slept through it, but maybe you didn't like explain why exactly it didn't work out for you.
The frame rate was not really good. The Logitech C920 is very expensive. It's very consuming of CPU. Like actually,
was dropping
if you see the requirements of this webcam, they said that you have to have like a E3 for minimum.
Oh, so like what's the actual resolution of the video with the Logitech?
Yeah, and well, was the camera is CPU consuming to get the frames out of the camera. The second is that they have to be encoded and then sent to the server, and then it has to receive another one. And then sometimes you have to have multiple streams. Yeah. Means if you think like multiple streams in the Raspberry Pi.
It was not powerful enough to handle this.
I mean, it was like going 1 frame per second.
And if you put like...
And it was not receiving the second stream. It was just emitting. I mean, Raspberry Pi, my experience with it is great. It's great. But when you use, for example, Python and you take data, like for example, we don't have it still in Raspberry Pi, but we plan to move to Raspberry Pi, or actually now, luckily I have 2 Galileos, Intel Galileos. I don't know if you know this one. It's a really new one that just came out, Intel Galileo. It's like actually like Raspberry Pi. And basically, like Dreams of Cities, it could run in a Raspberry Pi. We still don't have in Raspberry Pi, and probably will move to. Because it's just that getting data and putting in a small database and making some calculations, that's easy. But like
when you have
getting
an
image that is certainly kind of big, encoded, send it to the internet, receiving another one. It's not I mean, you can Raspberry Pi, it works if you get like a streaming of maybe 320 by 240, and you have only this in the Raspberry Pi, and then it works. But if you think on getting this, receiving another one, and we're not streaming at 320 by 240. I mean, we're streaming at higher resolution.
And also the operating system, Raspberry, doesn't support all the libraries often. So
yeah. Also, we thought we thought okay.
Ubuntu is more better.
In going fast, in going much faster in development, we thought like let's not go in Raspberry, because that's what Barbara said. That many you are in developing something, and then you find out, oh, this library it used this and this and this and this, and Raspberry is still not supporting because it's Atom A6 like and certain things it doesn't work if you're not in Ubuntu and you have a Core 9.
So basically, like the dependencies were not met because they weren't ported over. Or something
the streamer it works. Like the dependency of streaming it works, but it's slow. Means Raspberry Pi is a question of speed that it was not. But also in terms of development, it will like add some extra time to us. Because like as I'm saying, like maybe some of the libraries we're using, it will be not compatible. Yeah. Actually, we had in the past to just like compile Phantom.js. I don't know if you know. Phantom.js is a webless library. Yeah. Like it was a huge work just to compile it for Raspberry.
Yeah.
Oh, and another follow-up question.
Yeah.
When did you like start looking at the
Raspberry Pi?
Yeah.
In January, this year, January. Yeah. Actually, one project we did, it's called Wireless Poetry. What we were doing actually with this Phantom GS library is we had dedicated Wi-Fi router, and we were constantly changing the names of Wi-Fi. replacing actually by the poetry lines. So you can, like, normally when you come in, you straight away check, okay, what are the Wi-Fi's can I connect? And of course you can connect, but you will see also the poetry lines, and then after 1 minute you will be disconnected because we changed the name again. So we created, so to say, invisible work, so to say, but through wireless signals. And we collaborated, or we asked actually one Catalan poet to write some poems which fitted this 32 characters, which router actually allows you to put the name, SSID. And we got, well, we were in Korea at that time, and we got a nice router which had which allowed to have 4 networks. So it's perfect for like kind of the verse, or how to say.
2 non-encrypted and 2 encrypted, and we use the Phantom GS for interacting into the panel of the router and change the names of the Wi-Fi.
Yeah, so this was
because Phantom GS is like a webless, browserless library that you can interact with the browser without having a browser, and then you can go to a page and you can say, okay, take me this button that is the ID in the DOM that is named that, and then click it, and then go to next page, and then put this text in the form that is class and then and you don't see anything.
But what is nice about Raspberry Pi is like in terms of like if it's not like heavy projects in terms of software, it's very like money-wise effective. You just per project is 1 SD card, you know.
Exactly.
And you can back up, and you and
like
it's amazing in this sense.
For art preservation, it's great because you can have you go to a festival and you could have like 2 Raspberry Pis, which I cannot go to a festival with 2 computers. Like if I only use 1, I cannot go with 2 computers in case one breaks, right? Because it's too expensive to go with 2 computers. And also maybe even in customs I will have problems if I go with 2 computers instead of, I mean, if I go with 1 computer, they will tell, yeah, your computer, okay. But if I go with, and with Raspberry Pi, because it's cheap and everything, and you could, and like Barbara said, just like you have 1 project and you have one SD with the project installed there, you put the Raspberry Pi, boots, it's great.
Okay, at first I'd like to thank you. It was a really great presentation, and I'd call you art hackers in the classical sense. So it's very, very much like classical hacking culture. But I have a question about the music you used for the neural knitting system. I wonder how would a different kind of music work? For example, I'd use the Beatles, Enya, and Sex Pistols.
Yeah.
How would it work?
Actually, in Rome, like the photo we show, first we show with Golden Variation of Bach. That was the video. Yeah. And when we put 2 3 people, and then we make scarves. And then this was a proof of concept. But more recently in Rome, we just were saying to people, just choose the music you want, and we play for you. Because what we use just is like music as a brain stimulation. Like in cognitive science, like they explain basically that music is much straightforward to your brain affecting than visual input, because visual has a lot of calculation. It's like computer vision for your brain. Like if you have, for example, a danger, it's much faster to react to a sound of a car that is going to crash you than you look in a car, because that you look a car that is coming, and you have to identify that this is a danger, rather than if you listen something that you know in your brain is like featured as a danger. Your reaction will be much faster because it's much straightforward. Means when we are stimulating the brain, it's better the sound, and any sound actually stimulates the brain. Like Sebastian, for example, is working in one of his last papers that is working and also research It's like in doing sound, which is the sound who relax you more. And it's actually an abstract sound, but it's with feedback loop. It's kind of with your brain reaction. It's like modifying in the moment that they find the sound that relaxes you more. Did I answer? I think so.
Yeah, I actually had another question or like comment. So I play around with my own Raspberry Pi, so I guess it would be for food for thought for you guys. Like there was a recent update on the Fedora ARM operating system, and when I benchmarked and compared to the previous version, which used basically the same kind of settings like the Debian one, but my performance with the update increased by about 30%. So.
Okay. I mean, we check it. I mean, what we did is like we were like doing the prototype around, when was March, April?
Yeah, March.
Yeah, March, April. We were doing the prototype and we bought first the Raspberry Pi because, I mean, it was a cheaper option. I mean, it was great, but we tried it and it was like, I mean, it was not good enough. And we wanted to develop our own software, but we didn't want to fix the problems in the Raspberry Pi.
I mean, this is the mistake of Raspberry Pi. Why they didn't pay Linux to
Yeah. Well, we know actually this. I mean, because I'm a friend of one of the developers Arduino, like David Cuartellas. I know one of the reasons why Raspberry Pi had been like shit for like basically they didn't want to pay canopies. They didn't want to pay the Ubuntu people to make
this was their mistake
to make a good Ubuntu for them, and then and because they thought that they will go to Ubuntu people and they will make a version for it, and the Ubuntu people say, well, you are selling a product, why you don't share with us the revenue? And then they said, you have to you think that, I mean they didn't want, and then basically they have been like not having great Linux for some time, and they eventually they would have had if they would have paid, but they didn't. And I mean they just had to pay the beginning of the development, I guess, and then the maintenance will be like for free. I don't know, but then just we know that was like a kind of a.
But what we tried is another one was Panda board, where you can put like normal Ubuntu on it.
And at the end, well, I don't know if you saw, like we're using Nuke. Nukes are new kind of computers that Intel release.
They're amazing.
They're super good. They're like small like that, and they are E3 and E5, and they go with solid states.
But the price is different.
I mean, it's still cheaper than a Mac Mini.
Yeah.
And we run with Ubuntu, and they work. The performance, they work great.
And the size is very tempting. If you don't have space, what you are doing, it's very.
I mean, at the end, I mean, we really underestimate the beginning thing, like the performance thing at the beginning, because we had to run many things. Like at the end, we have to control all these computers. I mean. We have to have TeamViewer on it. I mean, we have to have like several things that they're not needed in theory, but they're needed in reality, because you need to control, you need to monitor them, you need to access it to it.
But in this sense, we don't have real experience with Raspberry Pi, how stable and automated it can be. I mean, they can be as automated as is our Ubuntu 12.4 LTS, but the problem is that some libraries they will not run. I mean, because the atom that they has, that they are not compiled for these atoms. I mean, now, for example, I work a lot with Open Frameworks, and Open Frameworks recently has like the 8th version. Everyone knows Open Frameworks? No? Yes? Any hand? No one knows Open Frameworks, right? Okay, Open Frameworks is a framework for creative programming, and is in C++. And anyone knows processing? Okay, it's like processing, but in C++. And I have to tell that,
Like basically now there is a lot of demand actually in work, for example, in open frameworks. Like New York Times hiring people now with open frameworks people. Like many agencies of advertisement is hiring people with open frameworks. So it's just like for everything, like actually, like there is a lot of libraries done by people in open frameworks, done many things. It's like a glue, it's a framework of gluing a lot of C++ libraries. And yeah, it's great. And recently, open framework runs in Linux, Mac, Windows, Android, iPhone, iOS, and Raspberry Pi. But for I was following I'm not in the core team of developing anything. I'm just a user, and I was following the development. I know also people who is the core developers, and basically they had to adapt many libraries for that it runs in the low atoms that the Raspberry Pi has, like the Glut. Glut is the Windows library. The general Windows library, it doesn't work in Glut. They have to change this. It means they have to, I think it's Glue or something. I don't know. It's another library because Raspberry cannot support that, basically. Means, yeah, it can do everything. But I mean, when you do Python, it's great. Like I said before, like you do Python, it's just fantastic. You like most of the library of Python works, and yeah, the performance is great, but if you want to do some kind of other things.
No, it's good to know different platforms and different technologies because everything has its own purpose and its own.
Yeah. And for example, now processing is great. Lately, since it became a foundation in America, I also know the founders of processing. And 6 months ago, like they create this foundation on processing, and now it's a foundation. Means it's great because the foundation, the aim of the foundation is keeping this framework for creative technology in Java that is called processing, and they also did for I think it's if I don't know if I'm mistaken, but it's the first time that they entered in this Google Summer Code. Everyone know Google Summer Code? It's super great for students because they can collaborate to open source projects. And I think they got 3 positions doing things. And one great thing that came out is called processing PDX. And actually the idea of processing, it used to be kind of not very great, easy to teach people because it just has a play button and just will compile and these kind of things. But you could not debug. Like you could put a pointer and just basically go by line and do like a debugging normal thing. But recently with the PDX, this idea just go. You can compile, you can debug, you can pass line by line, you can replace variables that the name in all the files. You can find if a variable is not used in any place. Things really like a proper compiler with the easiness of that it has before. Means it's kind of great because sometimes even me when I go to I use, for example, time to time Eclipse. I don't use every day. When I go back, it's just like, oh my god, where are the things? Because I'm not using Java all the time.
First of all, thank you for a wonderful presentation. And my question would be that before you mentioned 3D printing and the potential of it, also that many people will have it in their homes in the future. Also, some people have said that it will be the third industrial revolution. So, what's the take? What do you think about it?
We just bought a 3D
We
printer.
just bought one.
We have one DIY in the process of working, but this is kind of a process. And we just bought one. We bought a microbot. 2X, and it's coming actually in Estonia soon. I think it's great. And actually, I was reading something this week that I don't know. I didn't comment to you, but it was really fascinating because it was saying like one strategy of making poor all of the people in the last years is the desindustrialization. You take the example was Detroit. You know the story of Detroit in America. Detroit was the Ford, like General Motors, had the headquarters in Detroit. Detroit was a city that car manufacturing started in America, and it started in Detroit. Even the whole America kind of dream of that you can do whatever with your life and that you can get anything if you work hard, everything like this, it came from this idea of Ford, that the owner of Henry Ford, the owner of General Motors at the time, that he will pay good to his employees and they could buy a car and a house. And by disindustrializing the areas, and just saying that the services will sustain an area is a way of making poor the areas. And I think they're right. I totally think that if an area that don't have manufacturing power, it will be poor sooner or later. Financial services and all these kind of things are just big bubbles. And you see now, you see with the financial crisis what happened, how the money blows, and then we say, what is the money now? The money disappear. But the things that, when you have manufacturing power, this is a power. This is a real thing. You can do things. You can manufacture like the knitting machines. They can do end products. That's amazing. You can do things that you can wear right away. You can do scarf. You can do T-shirts. You can do a blanket. You can do with the 3D printing.
It's still not there.
It's still there. You cannot do end products sometimes. You can fix the stuff, which is great, because I don't know, your kettle broke the hanger. You can just print a new one.
No, but Mark, how many people actually are doing this? Because the thing is, the third industrial revolution, it's a nice name, but it's still not there because most of the people who actually have 3D printers, what they are doing, they are printing things from Thingiverse, like some toys. Not all, but I'm saying most. The architects, they are printing their models, but the thing is, if you have 3D printer, you have to learn how to 3D model. Then you have to understand also slicer, because, the slicer is how it puts you the layers of the filament, and how it makes the algorithm, basically. And the thing is, we have been working with several 3D printers from Prusa until the MakerBot and more professional. The thing is that the quality is still not so good. MakerBot is quite good, but
it's not even the 3D printing. I believe in the maker movement. I believe in the movement of people regaining knowledge of producing things with the digital tools. And not only the 3D printer, because with 3D printer, I will tell you, for me, more useful is a CNC. You have a good CNC, and you mill any kind of wood, and you mill, for example, aluminum, and you can do really good stuff with it. You can build you a car if you want. Seriously, you have good aluminum. Most of the cars that you see in the streets are aluminum based. Or wood stuff. You can do chairs, you can do many things that are done with wood. strong wood, not the wood that you cut with the laser cutter. Like the wood that you cut with the laser cutter are soft wood that is kind of
MDF.
well, it's good, but it's just like a support material, like something that you don't need to have like have a strength of it. But the 3D printer is great. I mean, I'm not saying that but it's not the ultimate solution. But I think the ultimate solution is the idea of people. It's like the same of open source. I believe in open source means I believe in the maker movement. I believe in people learning how to do stuff and doing stuff, and having manufacturing power, like that don't have to come things from China, and that the same thing that like this flag pack from IKEA. This we could do everything if you have a CNC router everywhere. You just put the wood, and then you have like Illustrator files, and then you put this magic inside joints that they use in IKEA, the inside nuts. These ones that you put and then you put all together.
But the third industrial revolution is also about like there is people have access and knowledge about computer-aided manufacturing. That you can really the people who know how to code or design with computer actually can make it also physical, and the DIY machines that slowly like they are now increasing their size and the quality. I mean, now also like we know like one designer in Holland is developing like one 3D printer which is really 1 meter by 1 meter, and they are experimenting with other materials which are more cheaper. So I guess there is well, the movement is there, and but there would be more exciting times.
3D printer it can go with different materials, and maybe the ABS and PLA is not the one that will save our daily life. Maybe it's more, I don't know, another kind of product that can be similar machine but bigger, because they are small.
They are very small.
Okay, I see that probably you have much more questions, but we are right now have run out of time. But maybe Varvara and Mar stay a little bit longer, and if you can ask your questions face to face. But thank you for your presentations, and we have something for you too.
Nice.
And
T-shirt.
Thank you for watching us right here at the college and online, and after that on recording. Thank you.